Good evening, guys. Welcome back. Good evening. Good evening. Who all are here? Only the Bargo is here. Okay. Okay. So let's start the class. So let's discuss the 2019 statistical inference problems. 19 ka. So let's do this first problem now. Um, the first problem tells you the question 9. The first problem tells you that if x1, x2, xn are random is a random sample from a continuous distribution with probability density function this as given above, then if t is equal to the sample sum, then which of the following is an unbiased estimator of mu? So I hope you can understand from here. This is sort of an uh, what can you tell about this? It's sort of a normal, looks like normal, right? So can you transform this into a normal random variable? That's the first hint. Can you transform this into a normal random variable? So it looks like a normal random variable like a PDF, right? So if it looks like a normal random variable like a PDF, therefore you should first try to make it look like a normal random variable. So say fx is equal to, like in the form of 1 by root 2 pi sigma, right? So you can understand from here that sigma is equal to 2. If it's a normal random variable, sigma is equal to 2. If sigma is equal to 2, therefore you have, hello Shavya, if sigma is equal to 2, you get that if sigma is equal to 2, you get the following, that exponential minus half, you take common, so you get x square plus 4 mu square plus, sorry, minus 4 mu plus x square plus 16 mu square minus 8 mu. Okay, and therefore you get the following. So I think there will be some two commons out, so let's try to write this down. So you get 1 by root 2 sigma. Sigma is equal to, you already know, exponential minus, they get half into 2 square by 2 square. Okay, so you get already 2 square here. Let's see what you give in the above. Okay, get in the above part. So you get the following, because it's a sigma square stuff. Okay, so yeah, it's a sigma square stuff, and let's see. So sigma square, now here what it's 2 x square plus 20 mu square into 4 is like this, mu square minus, it will be 8 mu x, 6 mu x minus 12 mu x. So what ideas do you have, guys? Tell me. What ideas do you have? Or it's something else? So can you make it into a normal looking stuff? That's the main question over here. Can you make this look into normal random variable? This expression mainly. Yeah, perfect. So it is rather like this. It's product of two normal random variables. Can you see that, guys? Exactly, perfect, very good. So you can see this, it's a product of two random variables, like product of two distributions, rather two normal random variables in that sense. So yeah, so how can you do that? How can you, like, so what is the probability distribution of this? Can you tell me? So it looks like that it's half into uh it sort of looks like half into normal mu, like it looks like this. So therefore it doesn't look good in this aspect. Okay, product of two random variables is not a random variable, normal random variable. So it's rather you cannot really do like this. So rather you can do it in a different aspect. Let's see how you can do this. So rather what you can do is the following. Therefore it's not the right way to do this. So what you can do is that, like, if you assume two random variables x and y. So if you take x and y as two independent random variables, so x, so let's say not say x follows normal 2 mu comma 1, and y follows normal 4 mu comma 1, and x and y are independent. Okay, so what is the distribution, what is the density of x and y? Will the density look like this? Because in that case it will be root over 2 mu, right? Whole square. 1 by root 2 mu whole square will be there, right? So what is going wrong over here? You understand, Debargo? Suppose it's product of two normal, 1 by root 2 root 2 pi whole square will be there, right? How can you really do it now? Take that half outside. Okay, I take that half outside. Yeah, observe, perfect. So this is, understand this very carefully, that what you need over here is not this stuff. Okay, so you understand this is not the PDF of x plus y or something like that. What you need to count is that you need to understand that the PDF is sort of look alike normal. Okay, it's not normal, it look alike normal. How does that help? So you cannot really find out what is the density of this. Okay, it's really hard to find. It's like shifted normal. Okay, it's like elliptical, not elliptical anyways. So what you can understand from here is that it's different. So you need to find expectation of TC because you need to find the unbiased estimate of mu, you need to find expectation of t. So you just need to find integration of xfx. That is your aim point, not how to see it's normal. So that was my claim, that even it looks like normal, don't fall into that trap. Okay, you need to understand what you have to really aim for. Expectation of t is what you are aiming for. Okay, and therefore you need to find expression of xfx. It's not multiplication, xy is not xy ka pdf is not this. Okay, so what you need to do is expression of t, and if you see expression of t, this now you can use the normal wala stuff. It's integration half integration normal in it proves like this, that it's half times expectation of x plus half times expectation of y. Can you see that when you do xfx, you get like this, x and x over here. So this first part is expectation of normal 2 mu comma 1, and the second part is expectation of normal 4 mu comma 1, and half has common. So therefore what do we get? It's half times x ka expectation is 2 mu plus 4 mu, therefore you get 3 mu. So therefore expression of t by 3. Okay, now it's n, right? So if you do n, it's n times this, because all are IID. So it's 3 mu n. So therefore you need to just divide by t by 3 mu. Okay, that's the idea. You understand this, guys? It's very easy. Okay. So don't fall in the trap of looking like you have to get the idea. Okay, it looks like normal, but don't then try to factorize that stuff. Just I was doing actually I was doing a mistake. I was thinking it's plus this, so I was doing that calculation mistake. Okay, so let's move ahead to the next problem. X1, X2, Xn are random sample from normal theta comma 1. Instead of observing, just this is just basic unbiased estimator, okay, of normal, just that basic unbiased estimator wala stuff. So I should write it down here. Unbiased estimator. So X1, X2, Xn is a random sample from normal theta comma 1 distribution. Instead of observing x1 dot dot xn, we observe y1 dot dot yn, where yi is equal to e to the power xi. Now you have to do h naught is theta is equal to 1 versus h1 not theta is not equal to 1. Okay, so understand this very carefully. This is not Neyman Pearson lemma. It's normal theta comma, so it's a mu. It's a z test for mean, normal mean. Okay, it's a z test for normal mean. If it's a z test of normal mean, so you have the data yi instead of xi. Okay, so now what does the z test look like? Z test looks like this, that for, let's say you have the data yi, okay, sorry, xi. If the data is xi, let's try to write the test in terms of xi. X test in terms of xi. In xi का terms it's what? It's summation of xi. अगर बहुत ज़्यादा होगा तो reject, और summation of xi अगर कम होगा तो reject. This is how it looks like, right? C dash. So it's a rejection region. So therefore now if you just write xi is what? So now you need to find e to the power y xi ka terms, okay? So therefore how do you find e to the power xi? You just need to take e to the power to this, right? To get e to the power xi form. So therefore it, since e to the power x is increasing, so if a is greater than b, e to the power a must be greater than e to the power b, right? So therefore it becomes e to the power c1, or some e to the power summation xi is less than e to the power c dash. So you get what? You get product of yi is greater than e to the power c1, or you can take it as some k, or product of yi is less than some k dash. Now is it in product? No product form, so they need to find in log form. So you just take log. You just take log. Log is also an increasing function. So a greater than b के लिए log a will be greater than log b. So take log. So summation of log I will be greater than log k, or summation of log I log yi is less than log k dash. So it's of the form what? It's of the form this, right? Rejection region, yeah. So likelihood ratio test is in the form of, likelihood ratio test is form, the likelihood ratio test is the z test form always. You must be knowing this. These are very basic stuff. Okay, so this basic results you must know, remember this. All of you understood this, guys? Is very easy. It's just basic z test, okay, and likelihood ratio test also. Any doubts, guys? Perfect. Very good. So let's move on to the next problem. It's a MLE problem. It's an MLE problem. So let -1 and -1 and 1 be the observed values of a random variable of size 2. Okay. So pretty easy, I guess. From normal theta comma theta. It's like curved normal family, okay? Shava, I hope you understood. So it's a curved normal family. And if it's a curved normal family, one second. Yeah. If it's a curved normal family, you get you just need to do maximum likelihood estimator of theta, okay? So first write down the it's just MLE, okay? Just like log likelihood. So just write down the likelihood. If you want to find the likelihood, and if you find likelihood, log likelihood, say you will get. So let's write the likelihood first. So 1 by root 2 theta, okay, exponential minus half. I don't know, Shoham da writes so beautifully on this board. I am so bad at writing this on board. Xi minus theta whole square by theta square. Okay, perfect. Sounds good. So this is the likelihood, and if you do log likelihood, take log of this is the, how do you write this? L of x bar comma theta. Why I'm showing this? Because when you will preparing for ISI MStat subjective, this is needed. Okay, log Lx of theta. Sorry, what I'm writing? Theta given x bar, x curl. That is the data. So theta given x curl, and you get that some constant is there, so some c dash c plus c minus, sorry, c minus log theta minus half summation xi minus theta whole square by theta square. One second. Yeah. So if you do this now, if you just now do the derivative of this, okay, just take the derivative of this, then you get that small l and del L del theta will be equal to minus 1 by theta, and here minus is there, so it will be minus half a times 2 summation I twice xi. Okay, it will be plus here, then xi minus theta. Oh, it's not plus. Wait, there's a confusion. This is not, okay, this is a bit difficult in some, not difficult, okay, I will write. So it should write it in different format. You should write it in a only theta format. So it's like xi by theta minus 1 whole square. Okay, so you get that it's twice xi by theta minus 1 times, here it will be plus, I'm just applying chain rule, times, oh, the 2 will be acidic, xi minus xi by theta square. Okay, it's minus xi by theta square you get. So what you get here, so you get that it's equal to 0, and therefore you get, let's do it, so 1 by theta is equal to this cancels, minus minus plus happens, so 1 by theta square is common, summation of I xi minus theta by theta, and this theta get cancels, so you get that theta square is equal to summation of xi minus n theta. So you get a quadratic. Very good. So you get a quadratic. So theta square plus n theta minus nx bar is equal to 0. All of understood this, guys? Perfect. So you know theta is greater than 0. So you can use this result now. And therefore, because it's a variance, a sigma square, yeah, sigma. So therefore, you can use the result, or therefore use Sridharacharya minus n plus minus root over b square plus 4n by 1 by 2. If you do this, observe that this, if you take minus, it will be positive, negative. So you must take plus. So the root theta is equal to, sorry, it's 4n x bar. I'm so sorry. Yes. So theta is equal to minus n plus root over n square minus 4n x bar by 2. Perfect. So let's see. Let's see what we get over here. We get that. Okay. So now you know what is x bar. X bar is 0. X bar is 0. So you get that minus n plus, what is, plus n by 2. Therefore you get 0. Okay. All of you understood it? Any doubts? Any doubts, guys? Okay, perfect. Let's move on to the next problem. Okay, it's an estimated problem. So x1, x2 is random sample from a continuous distribution with probability. So what can you tell me? What is this distribution? This is called shifted exponential. Okay, just location family. It's an exponential. If there was theta was not there, it's an exponential. So it's a exponential theta comma theta. Okay, the shifted exponential family, except exponential distribution. Okay, so if x1 is minimum of x1 comma x2 and x bar is equal to x1 plus x2 by 2, which of the following is true? Okay, so how do you find this? How do you do this problem? Tell me. So it tells you how to find out, ask you how to find out the sufficient and complete statistic, right? So do you know the algorithm to find out sufficient statistics? What is the algo? The way is Neyman factoration theorem. Neyman factoration theorem is a way to find out the sufficient statistic. Okay, for theta. You can easily do Neyman factoration also without using OP or like one parameter exponential family or not. And also you can directly do completeness. Okay. So let's do it in two different ways. One Devargo is doing, and one's the way we will do from the basics. We will do just from scratch. First principle, we will do one solution. And Devargo, can you do it using exponential family? OPEF. We will give two solutions different. So therefore you can write it as fx, you can write it in a single term as is equal to 1 by theta exponential minus x minus theta by theta indicator x greater than theta. You can always write it in this form, okay? And I think it is in OP exponential family form. Okay. Anyways, you can understand from here also. Just try to understand the theta. This theta ka kuch hai. This theta ka kuch hai. I mean, maybe you can try to find out the MLE of this theta. Okay. So see, problems will be around this curved exponential stuff and this basic stuff. Okay. So don't like. So if you have the basic clear, it's very easy for you. Okay. Anyways, let's do the name and factoration theorem. Name and factoration का लेमा से करते हैं, name and factoration theorem से करते हैं NPF. So from MPF, what we get is that we need to find out the data. So let's try to find out f of x1, x2. What is f of x1, x2? It's 1 by theta square exponential minus x1 plus x2, rather do twice x bar minus twice theta by theta. This is what we will get. Okay, and I think everything is fine. Yeah, this is minus this, so you can readily write let's say plus of this. It's not an OPEF, right? So indicator x1, the minimum sufficient statistic greater than theta. You understand, like if a indicator x1 greater than theta, x2 greater than theta means the minimum will be greater than theta. Okay, rest will follow. All of them are greater than theta. So this is the f1 x2. Okay, so can you write it in that form? What was the form? Can you find out this sufficient statistic? It's in the form hx times g of x given t and theta. Sorry, x of t, g of t given theta, tx given theta. So okay, so you need to find out x. So what is the x format? Let's have to find out the x format. X format is in terms of x bar. There is no x format rather over here. Is there any x format? Any x format over here? What do you think? You can understand it's not an x format because it's not an x format. Okay, and observe that this g of t, I mean this g of x, h of x must be equal to 1, and this g of x, observe that g of t is a function of both x1 and x bar, right? See, observe it, the x bar is there and x1 is there. So therefore given theta, so therefore what do we get? Therefore x bar x1 comma x bar together is sufficient. Okay, together is sufficient. Did you understand this idea? By naming in PF you get that x bar x1 is sufficient. Okay, x bar comma x1 is sufficient. So this one or this one will be correct. Just you have to check whether it's complete or not complete. Okay, so first of all my question is, does this belong to OPEF? Debargo. No, Debargo is telling no, it's not OPEF. Okay, let's see why it's not OPEF, why it's not one parameter exponential family. That's also important to understand because you have theorems for competence sufficient for one parameter exponential family. Okay, so why it's not OPEF? So let's try to understand why it's not OPEF. So do you remember how does OPEF, one parameter OPEF looks like? One parameter OPEF looks like the following. f of x given theta must be equal to h of x. F of x given theta must be equal to h of x times some exponential. So you can like h of x times g of theta times exponential some parameter t will be there, which is the sufficient statistic. Anyway, some parameter tx will be there times another a theta, n theta times. So one second, just give me a moment. Yeah, times tx times n theta. I can see that g of theta is 1 by theta square, h of x is 1, and the exponential you can easily formulate in this terms of exponential, right? E to the power, it's e to the power, it's easy to formulate, right? E to the power f, log f of this, log of this. Right? So in fact it's of the form. So tx you can also understand from here. Tx, if it's an OPF, right? It's an OPF, right? Because both the things will be there. You can take this as the exponential log of this. And we are observing within x greater than 3, x greater than theta. So it like it must also always be like 1. So it must be like, I hope you understand that. So therefore tx, you can understand tx is a function of so it's a tx is also a function of x bar and x1. So also by OPEF you can sort of tell that tx is sort of x bar and x like that function. Okay. Oh, I see. Maybe it's, oh, I'm so sorry. I'm so sorry. I'm so sorry. It's not in the form this. It's not in the form this. Sorry. Whenever there is integer random variable, no, wait, just let me think. Yeah, it's not in OPF form because it should be of the form tx times rho of theta. So which is not of this because x and theta is like together. Okay. It's x by theta and like you understand x and theta cannot be separated with each other, or can it be? But I think just for a minute. No, this cannot be. This cannot be. This cannot be. Yeah. Whenever there is indicator random variable, you cannot really separate this stuff. Okay. Whenever there is indicator random variable, this cannot be written in this product of this form. Okay. So therefore, in uniform is not an OPEF form. Therefore, this is also not an OPEF form. Okay. So no indicator random variable can be written in this product of this two. Okay. In the sample in the parameter. So therefore, no, like therefore exactly same. Nice problem. Okay. Nice problem. Yeah. Okay. I hope you understood this, why it's not possible, because this indicator random variable cannot be separated in tx into theta rho theta form. Okay. So therefore it's not OPEF and you cannot do it in terms of OPEF. Okay. So therefore you need to do the complete part now. We have done the sufficient part. Let's do the completeness part. Okay, so I hope all of you are understanding where I'm heading, how I'm heading towards it. So let's do that. So what is the definition of completeness? The definition of completeness is what? That. So what is the definition of completeness? So definition of completeness is that expectation Can someone tell me what is the definition of completeness? How can we check it's complete over here or not? Can you tell me? Here x1 is complete. Okay. Why is x1 complete? So if x is if t is complete, is g of tx complete? So you have to show that expectation of complete definition is that if expectation of g of t is complete is theta if expectation of theta is equal to 0, g of t, wait just a minute, if expression of g of t is equal to 0, that means g of t then g of t is equal to 0 with probability 1. Okay, so therefore yeah, that's the idea. Yeah, so functions of complete statistic are complete statistic, right? Functions of complete statistic are complete statistics. So can you tell me that whether it's a complete statistic or not? X bar comma x1. Is x bar a complete statistic here? What do you think? Yeah, think about it. I will give you some time. I just got a very good geometrical view of completeness. Do you know about this? Do you know a geometrical view of completeness? Do you know a geometrical view of completeness? Okay. Okay, so how do you get it? How do you get it? Tell me, how do you get it? Okay, so tell me how do you get it? How do you get it? Tell me. So we will find a function g, okay, such that expectation of g of x1 comma x bar is 0, okay, but g of that x1 comma x bar is not 0 with probability 1. We will easily find that example, okay. Let's see, and that is easily done by a linear combination of x bar and x1, okay. So let's see how we can do this. Let's see how we can do this. I think I have to add a, can we add, how can we add, can we add a diagram in between? This is bad. I hope I wish could have done. Okay, let's 28 continue towards the end. Let's say 28 continue towards the end. 28 continued. So we have got that x1 comma x bar is sufficient. Okay, so now what is the idea is that we need to find a g such that g of x1 comma x bar ka expectation is 0. Okay, so you may know that, I hope you know about this, that do you know that x1 minus theta, so x1, what is the what is the thing over here, x1, can you get the x1 plus theta is actually sorry, so here observe this very carefully, x1 x2 xn follows exponential theta, and this is location parameter theta, okay, location. Therefore x1 minus theta dot x1 xn minus theta follows exponential theta, actual exponential theta. Can you understand this result, guys? Yeah, can you understand this result, guys? This follows this. So therefore, if you call it y1 y2 yn, then y of 1 is same as x of 1 minus theta, right? Because we just take minus theta common. And you know that the minimum of exponential follows what? Minimum of exponential follows exponential. Can you tell me what it does it follow? Minimum of exponential follows exponential theta by 2, okay, and therefore you will get that expectation of y1 is theta. That will imply that expectation of x1 is 3 theta by 2. Looks perfect, right? Looks very perfect. So therefore expectation of x1 we got 3 theta by 2, and also we know that expectation of x bar is what? Is theta. So therefore what do we get? 3 theta by 3 by 2 x bar minus x1. Okay, I think I have done some mistake, just to give me a minute. I think x bar is x bar x bar x bar. What is the distribution over here? What is the density over here? What is the X bar is theta, right? You have deleted that, right? Wait, just a minute, just a minute. X bar is xi have expectation theta, I guess. Or twice theta. Yeah, I'm just worried. I'm just thinking that x bar, I mean xi ka expectation is theta na or 2 theta. I'm just confused about that. Just wait a minute. X bar expectation expectation of xi is what? Expectation of xi. Oh yeah, it should be 2 theta because yeah, it should be 2 theta. Perfect. I'm so sorry. This is not good. It should be 2 theta. It's very easy. We can do this by this example. See, x1 minus theta is exponential theta, right? So therefore, expectation of xi must be what? Exponential theta of that plus theta, that is 2 theta. Perfect, perfect. Yeah. So therefore, exponential x bar is 2 theta, that is x bar by 2 is theta. So therefore, what do we get? 3x bar by 2, no. 3x bar. So x bar by 2 is theta and x1 is 2 theta. Yeah. So therefore, observe that if you take the t, g of the following, that x1 comma x bar is x bar by 2 minus 2 by 3 x1 expectation of g of t will be equal to 0, right? But observe that g is not equal to 0, is not even here, because x1 plus x2, let's say x1 and x2, say x by 2 is equal to 2 by 3 x1, which doesn't make sense, right? Which is not true, which is not true. So therefore we get x1 is equal to thrice x2. Yes, which is not true. So therefore we cannot, so therefore this is not true. Okay, so yeah, this is the idea. All of you understood it, guys? Any doubts? Any doubts? Perfect. So let's move on to the next problem, guys. Exactly. So therefore it is not complete, okay? Because we have got a function which is not equal to 0, but g of t is that is equal to 0 expectation. So it is not complete. Okay, so let's move on to the next problem. Okay, hypothesis problem. Let x1 x2 xn be a random sample for a continuous distribution with probability density fx. Okay, by the way, I'm giving a link of completeness and some geometry of completeness in this to you in the WhatsApp group. Okay, please check that. There's a so completeness is sort of. I will give you an example of. I will delete it over here. So completeness is sort of it's telling that what is completeness? It's summation of so my laptop hang just a minute. Completeness is this expectation of g of t is 0 implies g of t is 0. So let's do it in a discrete format. So it implies that summation of g of t p of t is equal to 0. Okay, implies that g of t is equal to 0. What does it mean? This means that if you like connect it to the linear algebra aspect, it means that you can sort of view this as the dot product of g1 comma so g comma 1 g comma 2 करते करते g comma n and p comma p of 1 p of 2 करते करते p of n इसका dot product. If you do this you get 0 and you mean that the g of this is perpendicular to this one. Okay, yeah. Yeah. So therefore, it implies that whatever the probability is this g of will be this implies that g vector is 0. Okay, so what does it mean, guys? This means that rather it's like if you just understand this, it's like if you consider the summation of gi, so then it makes sense. Okay, if gi, I mean the summation of gi, if you take and divide by this, then it makes sense that if g and f and g are two distribution functions, then their corresponding densities ka perpendicular, like they are orthogonal. Okay, so that is the idea. So that is the idea. That means completeness means that it's a collection of distributions, okay, for all possible values of theta, provides a rich sufficient kya bolo so it's like the probability is sort of a rich sufficient set of vectors which spans the whole, I mean the density is sort of a rich sufficient set of vectors, so in some sense, such that it spans the all the possible values of theta. Okay, so it's a family of distributions. Okay, in that sense. Anyways, so let's not go into this too much. Okay. Okay. Okay, so let's move on to the next problem. I will rub this off. So it's just spanned. I will give this PDF in the. I will save this PDF. I'll give it later. Okay, I will give this PDF here. Next problem. So okay, so it's I can understand from here. It's just an I think I've done this problem. It's just an name and Pearson lemma problem. Okay, NP lemma. It's an NP lemma problem. And if you just let's apply this. Okay. So if NP lemma tells that F0 by F1 must be less than equal to C. Okay, बहुत छोटा होगा. It will be very less to reject. Okay, this is a rejection region. So therefore you get that some constant whatever e to the power minus x square plus twice mod x is less than equal to C. Okay, and you take log, therefore minus x square plus twice mod x is less than equal to log of C. And therefore my x square minus twice mod x is greater than equal to C dash say. So therefore you get that mod x minus 1 whole square is greater than equal to C double dash. But is the question wanting this or not? So let's check this. So now if you take Fi, so it will be summation, it will be product of this, okay? So it will be summation of this. Okay, it will be summation of this. Because you're taking a product. It will be summation of this. The summation of this, therefore. Okay. So that's perfect. So therefore you get summation of x mod xi minus 1 whole square is greater than equal to C double C some k. Okay, that's what you get. Simple stuff, right? Simple stuff. All of you understood it, guys? Any doubts? So therefore it's this. Any doubts, guys? I think there shouldn't be any doubts. So yeah, so therefore let's do the 30th problem. If x1 x2, okay, I can just see it's a normal mean problem and it's a NP lemma problem. Okay, I think it's an easy problem. So what I can see is that like it's z test and it don't even z test is required. It's just NP lemma. So you know the rejection region looks like this. Rejection is like x bar summation of xi greater than C. Okay, because theta greater than 0, theta 1 is greater than 0. So xi greater than C. Okay, so 3n by 4. Okay, so this is a rejection criteria. So we have to find the probability this. So let's try to find the probability. It's very easy, I guess. Summation of 1 to n xi greater than 3n by 4 given theta is equal to 0 is less than equal to 0.05. And if you just calculate it, that summation of xi follows normal 0 1 है ना n. So therefore probability so therefore if you just do root n 1 by root n it will fall normal 1. So if you just do 1 by root n you just root n over here. So you get probability z greater than 3 root n by 4 is less than equal to 0.05. That means I mean 0.05 means this, right? So therefore इसके less. So therefore we need to find the maximum n, right? The maximum n value. Minimum n value. so that it's less than equal to this. So jitna bada hoga, this will become more than this. So therefore n should be maximum over here. Therefore you can understand this probability z equal to 3 by root n by 4 will be equal to this point. Okay, so what is this point? This point is the same this point, right? जिसके बाद, so what is this point? Can someone tell me what is this point? This is 0. So इसके बाद it will be 0.05. Therefore, sorry, we need this point. I am so sorry. So this therefore z 0.05, I think. If z 0.0, yeah. So therefore you get that this is this point. And do you know this value? 0. Normal 0.5 ka interval. Let's see. What is the value? Just give me a moment. 0.95, I guess. Just give me a moment. What is no? Did I do some mistake? I think, sorry, it's 0.95. So this is 1.65. So this means this is like, this is sort of 3 by root n is 1.65 around 1.65. So you get that a root n is around greater than equal to 0.2, the 2.2, and n is around greater than equal to 4.84. So minimum sample size you need 5. Okay, so yeah, that is the idea. So this is 1.65. This point is 1.65. 1.6. Such a bad handwriting. Okay, all of you understood this, guys? Any doubts? I hope there is no doubt. There is no doubt over here, I guess. Okay, so here it is, and that's it. So let's move on to the next problem now. The last 2 problems are left. So x1, x2, xn is a random sample from uniform theta comma 0. Also, I just remember the homework. You can also find out the minimal, the complete sufficient statistics from uniform 0 comma theta, okay, for theta, and also for theta 1 comma theta 2, a comma b. Prove that x1, x2, x1 comma xn is a minimal and the sufficient and complete statistic. Okay, prove that. Okay, so uniform theta comma 0, theta is less than 0. Remember, it's a different stuff. And Tn is equal to minimum x1 dot xn, which is the following is a consistent for theta. So consistent is what? Consistent is, do you know what is the property of the consistent? In probability convergence. Okay, so that is theta hat n is converging in probability to theta. Okay, that is what it means. In convergence in probability to theta, that means consistent. So we will prove something. Okay, so do you know, so do you believe that MLEs are consistent? Do you think so? MLEs are consistent? So there is result that MLEs are consistent. Okay, MLEs are consistent. So you can use that, and also if theta n goes to p and g is a continuous bounded continuous, g is a continuous function, then g goes to g theta. G is bounded. G bounded continuous. Not bounded. Okay, I mean g is continuous. I'm so sorry. Just let me check one the condition. G is whether bounded or not is important or not. Just give me a moment. So therefore, if theta n goes with convergent probability to theta, then this Tn convergent probability to theta, Tn minus 1, does it? No, it converges to theta minus 1. This, yes, because this converges g theta plus 1 by n, which also goes to theta. And this, no. Okay. Continuous से ही होगा सिर्फ. I just forgot the result. Bounded is not required. Just let me check. I think bounded is required for indistribution and convergence. Yeah, continuous mapping theorem. Yeah, for every continuous function. Yes. So it's called continuous mapping theorem. It's called CTS mapping theorem. So therefore, MLs are consistent, and you can use that property that to find out that, okay, all of you understood this. I mean, all of you understood this. Tn goes to theta. Now Tn minus 1 goes to theta minus 1, which is not theta in probability. Tn plus 1 by n goes in probability to theta plus 1 by n ka limit. That is 1 by n goes to 0. So therefore theta. And here it also goes to theta minus 1. So these are two. So now you can also prove it directly that this is consistent. Okay, Tn is consistent. But you can use this result over here. You can also prove it with Tn is consistent. How can you prove it? Just apply the result. Okay, just apply the result. So what is the PDF of this? PDF is fx is equal to minus 1 by theta. Okay, because theta is less than 0. For x greater than less than 0 and greater than theta. Okay, and observe that MLE is therefore x1 is greater than theta, so its MLE is x1. Okay, not xn maximum. It's a minimum because theta is on left hand side. Okay, so if you just, these are just intuitive stuff you just develop by practicing. No, I think for in distribution convergence we need a bounded stuff. Bounded, we need a f to be bounded. No. Oh, okay, I see. That also doesn't require bounded. So somewhere required bounded. Some condition required bounded. I forgot. Oh yeah. Expectation ka stuff requires bounded. Yes. Yes. Yeah. Okay. Expectation of that. Okay. Fine. Koi baat nahi. Okay, anyways, so you can also prove it directly, find the distribution of this, okay, and prove it directly. Let's do that because that's also important, because that is really important for many problems. Okay, so suppose it was given that Tn minus 1 by in that sense. So anyways, so let's do that, and therefore what will be the distribution of x1? So let's try to find out 1 minus probability. So let's try to find out the distribution. F of x1 of x is what? Probability x1 is less than x, which means 1 minus probability x1 greater than 1 minus x. Okay, so therefore what you get? You get that yeah, so you get 1 minus f of 1 minus x whole to the power n. Okay, this is what you get. And yes, so if you just do this is x minus x by theta, so you get 1 minus, so capital Fx is minus x by theta, right? So 1 minus, so minus of, so it will be plus by theta whole to the power n. Okay, so this is what is f of this. And what do you want to show? You show that probability x1 minus theta ye less than epsilon goes to 1, right? This is what you want to show. No. Okay, in this case continuous functions are bounded. Yes. No, on a closed interval, you see, that's why it's important. On a closed interval, you see, for example, if it's an open support, like long, like big support, then support means where it's non-zero. It's an infinite region. Infinite in terms of like the limit upper bound and lower bound is infinite, so it will not. Anyways, so let's compute this. So therefore, it's probability x1 greater than theta plus 1, less than theta plus 1, and greater than theta minus 1. Theta minus epsilon. So therefore, it's get that it's 1 minus 1 plus 1 minus theta minus epsilon by whole to the power n minus 1 minus 1 plus 1 minus theta plus epsilon whole to the power n. Okay, and you get that one gets cancelled. You get one get cancelled, so you get, it's like, wait a minute, did I do something wrong? No, yeah. So it's like 1 plus epsilon minus theta by theta whole to the power n. I think I am doing some mistake. Yeah, I think it's outside is that. Yeah, whole to the power n minus 1 plus 1 minus theta minus epsilon by theta whole to the power n. So let's see what it turns out. It turns out the theta get cancelled, and you get and you get 1 minus epsilon by theta, 1 plus epsilon by theta whole to the power n minus 1 minus epsilon by theta whole to the power n. Okay. Can you show it from here? I think yes, you can. Or can you? Did I do some mistake, guys? Can you just check once? Did I do some mistakes? I think we can show from here that it goes to 0 as n goes to infinity. Theta is less than 0, so we don't even know the value of theta. How can we tell this? Not sure. Did we do this correctly? Theta plus epsilon. Oh, oops, I think I did it wrong. Yes, so observe it very carefully that x1 must be greater than theta. So it cannot be theta greater than 1. So it is same as telling that it's greater than theta. So yeah, it's probability same as probability theta less greater than x1 less than theta plus epsilon. Okay. Yes, because x1 is always greater than theta. So it will be theta over here actually. Perfect. It now makes sense totally. Yes. So therefore it is 1 epsilon 1 chala gaya. Yes. Wait. So therefore this means this, okay. So does it go to 0? Epsilon is small, so epsilon is less than 1. So theta to the power n. Theta agar bahut, okay. Theta is fixed. Okay, we have to take theta fixed. If theta is fixed, yeah. If theta is fixed, okay, perfect. This is the analysis part you want to take in over here, okay? It's 1 by theta whole to the power n, or rather wait. 1 minus epsilon whole to the power n by theta to the power n. Yes. So therefore, okay, this is actually, this was not required. It's already given over here anyways, but yeah. This is get cancelled. Epsilon is not there over here. And yes, so 1 by theta whole to the power n. But like, okay. Sounds good. But we have been stuck here by theta to the power n. We must show that this goes to 1. I think this goes to 1 because have I done some I think this theta to the power n will get cancelled somewhere. You do some calculation mistake, guys. This should go to 1. This goes to 0, I am sure. So I think I have missed some theta to the power n somewhere, you know. I missed some theta to the power n somewhere. Oh, I see where I have done the mistake. I have written this wrong. Yes, I've written this wrong. See, integration, I think it will be theta. When it's theta, if you put theta, fx is not x by theta, because if you put theta is -1. So fx should be 0. So it's like x, it should be x minus theta, I guess. So theta minus x. If you put x minus theta, if you put 0, yeah. Oh, f of x should be x minus theta by theta. If you put 0, theta over here, it's 0. If you put 0 over here, it's theta minus x, it should be. That is 1 minus theta minus x. That is 1 minus x by theta. Ah, perfect. If it's 1 minus x by theta, yes. So therefore you get theta minus x by theta. So you get 1 minus x is theta minus 1 plus x. Theta minus 1 plus x. And therefore, am I doing it correctly? No, I'm just calculating this so that you become confident on how to calculate consistency, because always it will not be MLE, okay? You have to calculate this stuff. So I'm just showing that how to calculate this, okay? so that you doesn't get confused and baffled by the calculations over here. Okay, so you must know how to calculate this. That's it. So I think this theta to the power n will get cancelled here. Okay, that's what I personally feel over here. So I think theta to the power n will get cancelled somehow, and do the calculation and let me know. Okay, I think this where I'm doing some mistake, but we are going running out of time. So I think we can do this easily. Okay, Shavya and Devargo, I hope you understood. But yeah, that there is no need of calculating this, but I just calculate this because I show the calculation way, because you will be given problems like this in the exam. You can be given. I'm sure you will be given ISI. Okay, ISI will not give this straight cut problems. ISI don't request straight cut stuff. ISI will be asking you to find the consistency, probability, and then find the limit. Okay, and in fact, IIT will also ask so. But yeah, but I'm just doing it for that purpose. Okay, nothing more, so that you get comfortable with the calculations and not always try to do theorems. Okay, so x1 x2 xn random sums from continuous distribution with probability density for lambda greater than 0. This is this, so it's an unknown probability distribution. Okay, and you can understand it's like, oh, which are the following statements are true? The statements are not given. This is so bad. Oops, I'm sorry, just let me check. I think you can also use the consistency of the idea of the consistency. You can find the variance of that and show that the variance goes to 0 by Chebyshev inequality. You can also show consistency. Okay, so consistency show करने के लिए दो तरीका है. Only two ways are there. I not only two ways, the two ways are there. The two ways, one is showing the Chebyshev inequality, variance goes to 0 and probability goes to that stuff, and that is computing directly. Okay. Anyways, if you do this problem, I think it's let me check the 2019 wala problems. Sufficient principle. What is sufficient principle? Can you tell me the result or what you're telling about? Question number 40, right? It's 40. Okay, I've got the problems. 40, 40, 40, 40, 40, 45. Yeah, I got it. Okay, yeah. Yeah, that is true, Devargo, but I'm not understanding. Like, is it an unbiased question? I don't know. It's asked the consistent question, right? So where's the unbiasedness coming up? No, it's the other way around. It's on if and only if, right, Devargo? You cannot use that. It's systematically unbiased, hence it's consistent. You cannot use that, right? You can use Chebyshev inequality at most. That asymptotically it's unbiased, and the variance is going towards 0. You can use that. Yeah, you can use this. Asymptotically it's unbiased and variance is going towards 0. That's what I'm telling. There are two ways. Usually you can show asymptotically unbiased and variance is going towards 0, or you can show and find out the entire thing. I think essentially you have to find out the density at the end of the day. So yeah. So let's do this last problem. So yeah, so it's an you can understand from here that UMP is can understand how UMP is a NP lemma. Okay, so you just apply NP lemma, and if you apply NP lemma, you get that F naught by F1 is less than equal to C is the rejection criteria, and you get that twice half x e to the power, oh, it's a random sample over here, so it's 2 to the power n, but that constant will be there, so lambda to the power n x to the xi, x product of xi will get cancelled. C to the power minus lambda summation of xi square given lambda is equal to half by lambda to the power n e to the power minus lambda xi square given lambda is equal to 3/4. So you get that half by 3/4 whole to the power n is what? Some constant, okay? That doesn't care, that doesn't matter, okay? So you essentially get that this is then equal to c, essentially get that e to the power minus half summation xi square plus 3/4 summation xi square is less than equal to c, and you get that e to the power 3/4 minus half is 1/4. So 1/4 summation xi square is less than equal to c. That is the test criteria, UMP. It's an UMP, it's a MP. So the most powerful test exists for each value of alpha, right? It exists. And most powerful test doesn't exist, it's not true. If a more powerful exists, it's of the form reject summation of xi square. You can again take log of this. So if you take log of this, it's summation xi square is less than equal to c dash, which is true. So the main lemma is from this. Yes, perfect. So these are the two regions. Okay, that's the idea. So yeah, so we've completed 2019 problem set, and it's quite interesting. I believe the most difficult problem was, I don't know, I felt most difficult was this one. This one was not difficult, but I think it required a bit of ingenuity. So this problem was really interesting. This required the maximum amount of time rather. Okay, so all of you, it was really nice discussing the problems with you. I hope you're enjoying that. Shavya and Devarga, others are not attending, so I don't know about them. So any suggestions do you have for our problem solving classes, or we will do the 2018 problem like this next day? Okay, bye bye, and see you in the next class. Okay, perfect, very good.